Hey guys, welcome to lesson 3, day 1. We are going to be talking about combining different functions. Okay, so the first one is when you're adding two different kinds of functions. So you might see it like this, which looks pretty scary, but all you're doing is you're adding together the function f of x and g of x and just combining like terms. Easy peasy. Same thing with this one. You'll probably see it like this, but you are just subtracting the two functions. Just make sure that you're distributing that negative sign to that second function. This one, it looks like this. It's just you'll be multiplying the two functions together. And then when you see it like this, that's when you are dividing the two functions. So be careful when you're dividing, make sure that you take into account any domain restrictions. So like in this case, g of x cannot equal 0 because you can't have a 0 in the denominator. Okay, we're going to come to the section here. Let's just practice the combining of functions with like addition, subtraction, multiplication, division. So we're going to go through this. Let me work through the first one with you. So in this one, I don't look at it the way it's displayed. I'm going to plug in -2 to my f function, and I'm going to plug in -2 to my g function. So if I plug in -2 here, I'm going to get 0. The square root of 0 is 0. If I plug in -2 here, I'm going to get -5. So I have 0 plus -5 is -5. So try to do the other functions and see what you get. Okay, guys, so I went through all the functions, and you guys have had these before, so they shouldn't be too scary. You're just like substituting them in. What gets a little tricky is when you have the x. And so what this means, so I'm going to do this one. So f of x plus g of x, that's all that means. So I'm going to be just combining the like terms. So let me rewrite this. So this is f of x, this is g of x, and I'm just adding them together, which means I'm going to just combine like terms. So x squared plus x minus 12. So go ahead and see if you can do the rest. Okay, so let's kind of talk about some different things. So first of all, when you have a minus, this is what I was saying before. Make sure that you're subtracting that whole function. So I look at the like in parentheses, so I'm going to distribute a minus. So that becomes a +3. A lot of people leave that out. And this you're just doing the box method or foiling, however you do it. Notice these two, I have the domain restrictions down here. It's 3 because I have an x minus 3 in the denominator. And this one over here is x can't equal +3 or -3 because of these guys down here. But other than that, like division, you just cancel, and it should be pretty straightforward. So let's go back up here and talk about composition of functions. So composition, you'll see with like this open circle. And what this means is f of g of x. And here we're going to work from the inside out. So we're going to do g of x, and then we're going to put it through the f function. You'll see it different ways. So you can have it the opposite way. And this means g of f of x. You can also do the same function. Oops. So you'll see like that, and you're just plugging the like the answer to this back into the same function. So you're doing it twice. Okay, so let's kind of practice what I'm talking about here. So the first thing that I do is I rewrite this as f of g of 10. Remember how I said you're working from the inside out. So we're starting right here, and I'm going to plug this into the g of x function. So 10 minus 3 is 7. So that 7 is what I'm plugging into the f function. So I'm going to say f of 7. Now I'm going to plug that 7 in here. 7 plus 2 is 9. The square root of 9 is 3. So my final answer is 3. So let's do this one. G of f of 2. So f of 2, when I plug it into the f function, I'm going to get 2 because 2 plus 2 is 4. The square root of 4 is 2. So now I'm going to stick 2 into the g function, and I get -1. Okay, these are a little bit trickier because there is no number. So I'm going to go through this a little bit slower. So the first thing you're going to do is you are going to just rewrite what g of x is. So again, we're still working from the inside out. So g of x is x minus 3. You're going to take this whole function and you're going to replace it for that x in the f function. So let me show you what I mean. So anytime you see an x, you're going to put whatever that g function is. So right there, instead of putting an x, I'm going to put x minus 3. And then just simplify it like that. Okay, let's do this again. So now we're going to go the other direction. So my first step is just to call f of x what it is. So f of x is the square root of x plus 2. And I'm going to take this whole thing and replace it for x in the g of x function. So the square root of x plus 2, and then minus 3, because it's x minus 3. And that is your answer. So the most difficult part is this. I'm going to make these a little bit easier because these still complex fractions. I don't want to mess with that right now. So we're going to call this 2x plus 1, and this is x over 2 minus 1. And we're going to show that both of these are equal to x when I do the composition. So let me show you how this works. So I have f of g of x. So just like we did before, I'm going to substitute that g of x in for what it is. So x over 2 minus 1. We haven't talked too much about inverses, but what we're doing is we are proving that these two functions are inverses of each other. So now I'm going to take this and I'm going to plug it into that f function. So instead of saying 2 times x, that x is this whole thing, like that. I'm going to distribute the 2. When I distribute the 2 here, these 2's cancel out. So I get x. I get x minus 2 plus 1. So I end up with x minus 1. If they were inverses of each other, it should equal x. So I know that these two are not inverses of each other. But if I were to make a little tweak and to make this a -1/2 instead of a -1, let's see what happens. I'm going to change that. And so when I distribute this 2 now, the 2's cancel. So I get x minus, and then when I distribute the 2 over here, half of 2 is 1. So x minus 1 plus 1. And these cancel out x. So I'm halfway on the road to proving that these are inverses of each other. So let's do the other direction. So g of f of x. So f of x is 2x plus 1. I'm going to plug it in the g function for x. So 2x plus 1 divided by 2 minus 1/2. So let's see. So I'm going to go ahead, since these are the same denominator, I'm going to combine like terms. So I have 2x plus 1 minus 1 over 2. I think it makes it a little bit easier to see because these 1's cancel out. And so I get 2x over 2. And the 2's cancel out, and we get x. So they're only inverses of each other if both of these simplify out x. And that is it. We are not going to do this one.